Here we will put everything we learned together just to make kind of summary. This is of course related to the factorial design and to help us understand optimization of pharmaceutical formulations. This is more or less a step-by-step summary that help us understand the different steps that you need to follow when you do your design or your optimization process. The first thing, you need to plan your experiments and your design. So you need to identify the variables and the responses. And then this should be followed by setting the levels. And this is what we said, low, medium, and high. And that is followed by the factorial design. And here, most of the time, we will do 3 to the power of 2, basically 9 combinations, 9 formulations. Then once we decide on all these, we will do the manufacturing or the preparations. So remember to do this in triplicate. So everything needs to be repeated 3 times to make sure we have enough stats to do the statistics, enough data to do the stats. And this is quite important, of course, to get reliable data. Um, Once we finish all formulations, then we start measurements. So basically checking for the response values. So quality properties. After that, we get the values, we fit the equation, and that is where we start getting the math and the fitting parameters. And once we get that, then we will be ready to generate contour plots and visualize the responses. And then finally, we are at the final step here to find the optimum. And here where we said overlay and we identify the best region. So in these animations here, it shows you how the fitting is done. On the left, it shows you how the data are scattered. Clearly they don't fit a straight line, as you can see here from the R2 R squared value. This gets much better as the data gets closer to the straight line. As you can see, the R2 value start to improve. So closer you are onto the straight line, and we said this is the residual or the outliers. Basically, you're moving away from the optimum. If you are interested more in data fitting, there is another series on what it means data fitting. You can refer to understand what is going on here. So clearly here, when things go with higher R2 value, means you are getting better fit. Now something is called residual fit, or residual pattern analysis. Basically this is the difference between your the values that you measure, and also minus the line you fitted to your data. You would expect to have a random scattering around the line. You shouldn't have any patterns here. Basically means your data are arranged around the line. So here, of course, the difference is 0. Basically means you have, if your imagine all your data are completely fitting the data, that would be 0, right? But there will be some difference, of course, and that difference should be random, basically, just your random nature. So the best thing here is the one on the left hand side. So you get a random distribution. Basically, there is no pattern. If you see a pattern here, which we call funnel shaped in the middle, or you could get something even worse, a curve, means the data, they don't really fit your regression analysis, and you really need to find a different model. And again, I suggest, if you are interested to understand this better, refer to the data fitting series. So just in a summary, when you try to fit your data using regression analysis, you really the best outcome should be the one on the left. So this is more or less a recap of the um, previous graph. Is basically when we have uh, an error, basically measured minus predicted values, and we are looking for a scattered, random scatter. You don't want to see any patterns, and this indicates you have a good model. If we have, like we mentioned, if you have any pattern and something like curved or a fan shape, that means there is a drift from the model that you're using. And we are using regression kind of analysis, linear regression, assuming we have linear regression kind of fitting. If you get any curvature, then that means there is a quadratic going on. So it could be a parabola, or you have an S-shaped, and then that doesn't fit, and that's why you have a drift from the random kind of distribution. And a fan shape is similarly, that means there is data they're not fitting well, and we need to have to transform our data. Perhaps you can just use some logarithmic scale, for example. Outliers, you need to, if you get basically too many odd values, then potentially that could be something wrong with the experiments. These are some common mistakes that can happen. So one potential or one possible problem that can happen is the level spacing. And we mentioned it should have, when you do the low, medium, high, we said that should have the same distance. If we don't, then that potentially can distort the equation. So for example, when you choose a variable 4, 8, 12, the difference is 4. 2, 4, 6, difference is 2. That's all okay. But you can't choose 2, 5, 20. That will distort the equation. So you must choose similar spacing. Some other mistake can happen. You predict something outside your tested range. The issue here, you are fitting within this range. So we avoid predicting outside the tested range. Another issue can happen is to ignore interactions. And we mentioned about the A3 value. And this is, if you don't really, if you ignore that, then you're missing quite a bit on the potential information that can happen due to interaction. Something really can go indicate experimental error is when we don't have repeats. And that it will make it very hard to assess the data. So we can't assess the variation and of course the standard deviation unless we have minimum of 3 repeats. Um, and then you need to be systematic. So it might, if you're changing other variables, so you need to be consistent. So you've got to choose 2, 3 variables, the independent variables, and then you systematically you measure the response. So you have to make good design, choose what are these variables, and otherwise that can affect your data and mix up. It will be basically very difficult to tell the actual factor which is changing your responsible for any change in the response values. Just a quick recap on the development workflow. So we start with defining the variables, the independent variables, and then we create a design, factorial design. We run the experiments after that to know the responses. We analyze the data, then we finally model our data to do to choose and find the best fit. And that ultimately, once we decide this, will allow us to find the optimum values that are or the equation that define the different factors. So optimal formulation.